So, probability is a ratio, okay? It's a ratio of times an outcome is likely to occur, okay? And again, we're talking about theoretical probability. Now, probabilities can be expressed as a ratio, or you guys know ratios can be expressed as decimals or percents, okay? Some notation here. The probability of a specific event can be given as P of E, or you can write in whatever the event is. What's the probability of rolling a 6? What's the probability of being Delta King? Alright? So the notation there, the probability of an event, P of E. Okay? Phones need to go away now. Alright? Now, our probabilities will always range between 0 and 1. Okay? 0 is something that is absolutely impossible. Okay? 1 is something that's absolutely guaranteed. So the probability will always be between those, and it is possible to be equal to 0 or equal to 1. Okay? You know, there are things like, what's the probability of rolling a 7 with 1 die? Okay? There are no 7s, so the probability would be 0. Okay? So there are cases where it is impossible, and there are other cases where it is guaranteed. All right, if we're dealing with dice, again, what's the probability that we roll an integer? Okay, well, we don't have any fractions on our dice, so it would be the probability would be 1. It's guaranteed. Okay, so there's another aspect there about probability in general. Okay, so let's look at our formula here. Okay, the probability of an event. Okay, the probability of an event is the number of ways the event can occur out of the number of possible outcomes. Okay, the number of events over the number of possible outcomes. Okay? So notice here we're calculating numbers. This is where all the counting principles that we looked at last week come into play. So let's consider back the table we looked at yesterday, and let's calculate a few probabilities. What's the probability of rolling 2 dice and getting a total of whatever? Okay? Well, first of all, how many possibilities did we have?
12. Oh no, 2 dice. 12.
Well, the sample space had from 2 to 12, 11 items.
It's the area of whatever that's called.
Okay, how many total different rolls could we have? 36. Okay? 36, and this is where, remember we said the sample space isn't necessarily going to have all of the possibilities. It only has all of the unique possibilities. Okay? So each of these is going to be something out of 36. And of course we could reduce them. Alright, and you should reduce them if they can be reduced. Okay? So, looking back at our table, how many ways could we roll a 5?
4.
4 different ways, okay? So, the probability of rolling a 5, you could write like this, is 4 out of 36,
1/9.
which is 1/9. Good. Okay? I'm not going to write the probability notation for every one of them, but okay, so here we're just counting. How many different ways can we roll a 5? 4. Okay, so 4 out of 36 is a 1 out of 9. Okay. How about the 3?
1, 2.
2 ways. Okay, so 2 out of 36 would be 1/18. Okay. A 9?
4.
4. Okay. So 4 out of 36 once again is 1 out of 9. Okay. How about a 7?
Why the 9 is 4?
No, 6.
7.
7, there were 6 ways.
No,
Okay.
I mean, why the 9 is 4?
It's the diagonals of the
4/36 is 1/9.
Why is 4?
Y is 4. If you look back at our table, we had 1, 2, 3, 4 different ways to get a 9.
Oh.
A 6 and 3, a 5 and 4, a 4 and 5, or a 3 and a 6. Okay? Alright, so the 7, there were 6 ways to get that, so that's a 1 in 6 chance. Okay? What's the probability of rolling a 1?
0.
0. Okay? You can't roll a 1. Okay? You can't roll a 1 with 2 dice. Okay? And how about the probability of rolling a 12?
1.
1 out of 36. Okay? There's only one way to roll a 12 with 2 dice. Okay? So, relatively simple in concept, but the applications are infinite. Okay? But this idea of probability comes back to this every time. How many ways could this event occur? How many different outcomes are there?
How would you make the table if you had the 3 dice? 3 or 4 dice?
If you had 3 or 4 dice, what you would have to do is consider all of these, and you would have to roll 2 dice first.
Okay.
And then make it rolling 1 die and the sum of 2 dice to make a new table. Okay? Or you could make like a 3-dimensional cube,
Yeah.
but that's kind of hard to see. But yeah, if you wanted to look at the outcome of rolling 3 dice, you'd have to make this table first, then list all 36 of these.
And then make the
Or actually just the 11 unique ones, and then go with the other one. If you wanted to actually find probabilities, you would actually want to list all 36, because then you'd see how many different times. You know, otherwise you're only gonna get, you know, when you do, hey, I rolled a 7 with the first 2, and then my third die was a 1. That's going to give you an 8, but that 8 should occur 6 times, you know. But that's a good question. Yeah, I mean, you'd have to work with it a little bit there. Okay. Now, with that being said, let's take a look at just selected, couple of selected problems here. Let's say we're drawing a card from a deck of cards, and let's say we want to find the probability that the card is a face card or an ace. Okay?
16.
Well, how many face cards or aces are there?
16.
16. Okay. Out of
52.
52 total cards. So you reduce that down, and that would be 4 out of 13. Okay? And if you think about each suit individually, 4 out of the 13 cards are face cards. Okay? Let's look at one of these here. These are a little bit, you know, we did ones like this. The sum is 6. Let's take a look at 16. We want the probability that the sum is at least 8. That means greater than or equal to 8, right? So let's go back to our table. How many ways can we get a sum that's greater than or equal to 8?
10 minus 26.
15.
15.
Oh,
Okay? A sum of at least
less.
8. Here's 5.
4, 3,
5 8s, 4 9s, 3 10s, 2 11s, and a 12.
I thought it
So-
was less than 8.
No,
No.
at least 8.
Oh.
At least 8 would be greater than or equal to. So there's 15 of those out of
36.
36. Okay? So you reduce that by 3 and you get 5 12ths. Okay? Alright, so let's take a look at this one. Here's one where we're given a table and we have a couple of different total rows, okay? This is kind of an interesting thing, but this is the type of thing that you can do. You can have the same data but look at it from different perspectives. Okay, let's read through this. It says 100 college students were interviewed to determine their political party affiliations and whether they favored a balanced budget amendment to the Constitution. The results of the study are listed in the table, where D represents Democrat and R represents Republican. Okay, and then you have in favor of the amendment, oppose it, or not sure. Okay? And here's the thing, if you don't understand what balanced budget amendment is, does that matter in the problem?
No.
No. Okay? So, again, with a lot of these, you're going to have to maybe filter through some of the information and determine is that relevant to solving the problem. Okay? Here, it doesn't matter. So it says, a person is selected at random from the sample. Find the probability. Okay, so here's A. Find the probability that, first of all, the person who is selected is a person who doesn't favor the amendment. Okay? Now, what does it mean that we don't favor it?
You're opposed.
Or
Or unsure.
okay, so we're finding the probability that we're opposed or unsure. Okay? So how many people are either opposed or unsure?
45.
Yeah. Here's opposed, here's unsure, put those together and you get 45 out of 100. Okay? So you have a 45% chance of getting someone who's either opposed to it or unsure because they're not in favor. Okay? Does that make sense? So again, it's not really that hard, it's just finding the right values to choose from the data you're given. Okay? Part B, what's the probability that we have chosen a Republican?
45. 45 out of 100.
Okay, how many Republicans are there? There's 45, so 45 out of 100. Okay, so again, 45%, or you can say that's 9/20ths if you reduced it. Okay? Now, part C, what's the probability that we have a Democrat who is in favor? So that's and, right? We want him to be not a Democrat or in favor, but we want a Democrat and in favor. We're going to talk more today about and or situations, okay? But in this case here, we can look at the table. What's the probability? We have a Democrat and in favor. How many of them were there?
23.
There were 23. Democrat and in favor, that puts us right here. Okay? And that 23 will be out of
100.
the 100. Okay? So 23 out of 100, 23% chance. Okay? So. Are there any questions about using this basic probability formula? Okay. What I want to do with you here, let's see. There we go. All right, we're going to do this one. All right, what we're going to do is I want to take a little bit of time here and give you guys the opportunity to practice some of these. We're going to go on and look at some additional things related to the probability, but we're going to take about 20 minutes or so. I want you guys to work together to try to figure these out, okay? So we're going to stop this for now.